Now the next problem, number 7. Solve the system of equations. Solve the system of equations. Solve the system of equations. Say dou z by dou x equals to 4x minus 2y. So first one, dou z by dou y equals to minus 2x plus 6y. It's the second equation. Solve the system of equations means we have to find the dependent variable z which satisfies these two equations. That is called as a solution of this PDE. So we are going to find the solution of this problem. So from first equation, from 1, we are going to do the integration partially with respect to x. From 1, we are going to integrate partially with respect to x on both the sides. Partially with respect to x on both the sides. Since we are integrating partially with respect to x, the constant of integration, we are choosing it as some function of y. And which implies if we integrate this partially with respect to x, we get z is equals to 4x square by 2. So it is 2x square minus 2y into x2, so 2yx plus f of y. I name this equation as 3. Now we are differentiating this with respect to y partially. Differentiating 3 partially with respect to y, we get dou z by dou y equals to, we are integrating partially with respect to y. Sorry, differentiating partially with respect to y. So this will become 0 because there is no y is involved. So the second term will get 2x plus differentiation of f of y with respect to y be denoted by f dash of y. Sorry, this is differentiation, so no need to add any constant. And this is we did this one from equation using equation 3, but the given problem dou z by dou y is nothing but minus 2x plus 6y. So we are going to equate this to minus 2x plus 6y as per the equation 2. So what happens? From this equation we get this 2x gets cancelled, so f dash of y is nothing but 6y. So we are going to integrate with respect to y partially, so we get f of y equals to integrate. So 6y square by 2 plus some constant of integration. Here this is nowhere doing, we are f of y is fully a function of y alone. So simply we will write the constant of integration as c. Only when z is involved we think of a constant as some function of x or y, anything. But here f of y is fully a function of y, it's constant. Therefore, so what is the solution? The solution of the system of equations given by 1 and 2 is z equal to, you can go here, see equation 3, in equation 3 in place of f of y we substitute this term, so I can cancel this, simply I can write 3. So 2x square, equation 3, 2xy minus 2xy. In place of f of y we put 3y square plus c. This is the required solution of the system of partial differential equations given by 1 and 2. So this completes problem number 7. Now problem number 8. Problem number 8. So by the substitution, u equals to x plus alpha y and v equals to x plus beta y, where alpha and beta are two suitable constants. Now what we have to do is transform the PDE, say dou square z by dou x square minus 5 into dou square z by dou x dou y plus 6 into dou square z by dou y square equals to 0. This to the form dou square z by dou u dou v equals to 0, and hence obtain its complete solution. So for this partial differential equation we are going to make this transformation given by u and v, then transform this big expression of 3 terms of partial differential equation into this partial differential equation. We call it as a canonical form, and then find its complete solution. This is what we are going to do. We are going to use the substitution here. Now, so for this problem, u and v are functions of x and y. Z now is a function of u and v, where we can still say that z equals to function of what is u? U in turn is a function of x and y. V is in turn a function of x and y. We can write like this. Okay. So now, see, we are going to transform this partial differential equation into a partial differential equation whose independent variables are u and v. So we are going to transform to that type. So, but using this transformation u and v. Now we are going to find what is dou square z by dou x square, what is dou square z by dou x dou y, dou square z by dou y square in terms of u and v. So you have to be very careful that this is a function of u and v, in turn u and v is a function of x and y, so that we can find those partial derivatives respectively. So now what is dou z by dou x? So what is dou z by dou x? first we differentiate with respect to u and u with respect to x plus dou z by dou v, and dou v is in turn differentiate with respect to x. Okay. This is dou z by dou x by dou u. So what is dou u by dou x? You can see here. So what is dou u by dou x? 1 plus dou z by dou v, as it is we write. What is dou v by dou x? Dou v by dou x is also 1. Therefore what we get? Dou z by dou x is same as dou z by dou u plus dou z by dou v. Now we are going to find what is dou square z by dou x. Dou square z by dou x square. This is nothing but dou by dou x of dou z by dou x. This is equals to dou by dou x of dou by dou x of. So what is dou z by dou x? Just now we found from the previous step. We write as it is. Dou u by dou z by dou u plus dou z by dou v. This is nothing but apply the property of differentiation. Dou by dou x of dou z by dou u plus dou by dou x of dou z by dou v. This is nothing but here first we differentiate with respect to u, and this u we differentiate with respect to x. From this step we are getting this plus now this is, now we differentiate first with respect to v, this term dou z by dou v, and then this v is differentiated with respect to x, because u and v are functions of x and y. So we get like this. So the next step, just a minute. Here make some change, because here this term is a function of so here first we differentiate with respect to u, then with respect to v. This dou z by dou u, dou z by dou u into dou v by dou x plus, now we go to the second term. This is expressed as dou by dou u into dou z by dou v, then this u is differentiated with respect to x plus, then you just differentiate with respect to v, dou z by dou v into dou v by dou x. Now we substitute the values. So this is nothing but dou square z by dou u square into dou e by dou x is 1 plus this is nothing but dou square z by dou u, dou v or dou v, dou u into dou v by dou x is also 1 plus this is nothing but dou square u by, to avoid the confusion we can write it in the same order, dou v dou u, and this is dou square is dou square z by dou u dou v and dou u by dou x is 1 plus this term dou square z by dou v square into 1. So we get like this, and these are, both these things are same. If z is continuous or if z is continuous, so dou square z by dou u square, and this one we can write it as 2 times dou square z by dou u dou v plus dou square z by dou v square. This is nothing but dou square z by dou x square. And now, so what is dou z by dou y now? Same like this we are going to differentiate with respect to y. You can see here z is a function of u and v, in terms of, in turn, a function of x and y. So now we are going to differentiate z with respect to y. So dou z by, differentiate with respect to u, then u with respect to y. Similarly, differentiate z with respect to v and v with respect to y. And now what is dou u by dou y from here? Dou u by dou y is alpha, dou v by dou y is beta. So this one as it is we write dou z by dou u, and this is alpha, we write it here, plus this is beta. This is alpha and this is beta. So plus beta times dou z by dou v. This is nothing but dou z by dou v. Now differentiating the above with respect to y again. Dou square z by dou y square equals to dou by dou y, dou by dou y of this term, alpha into dou z by dou u plus beta into dou z by dou v. To this alpha can be taken out. This is nothing but dou by dou y of dou z by dou u plus beta into dou by dou y of dou z by dou v. The same like the previous step, previous we found for dou square z by dou x square. We do the same like this procedure here also. We now concentrate on this. Dou by dou y of dou z by dou u. First with respect to u. Dou by dou u of this term and dou u with respect to y. Next we differentiate this with respect to v. Dou by dou v into dou z by dou u into dou v by dou v. That's it. Plus now the second term beta times, we concentrate on this. So dou by dou y of dou z by dou v same as dou by dou u, first with respect to u, then u with respect to y, plus next with respect to v, and this v with respect to sorry, and this is nothing but dou square z by dou u square, and dou u by dou y is alpha, plus this is nothing but dou square z by dou v dou u into this is beta plus beta times this is nothing but dou square z by dou u dou v into dou u by dou y is alpha plus this is nothing but dou square z by dou v square into dou v by dou y is. So now finally we write this one as alpha square into dou square z by dou e square plus alpha beta, and this we can combine, both are same. So alpha beta, here beta alpha, so I get 2 times alpha beta of dou square z by dou u dou v plus here we get beta square of dou square z by dou v square. Get like this. This is the expression for dou square y by z by dou y square. So by dou square. Now see, we are going to transform the given PDE. So we got dou square z by dou x square, we got dou square z by dou y square, the expressions we got in terms of u and v. Now we are going to consider dou square z by dou x dou y. So now dou square z by dou x dou y, this is same as dou by dou x of dou z by dou y. Just to dou by dou x of, what is dou z by dou x, sorry, dou z by dou y, go here, here, this expression, and we are going to write it there. It's nothing but alpha into dou z by dou u plus beta times dou z by dou v. And check, alpha into dou z by dou u plus beta into dou z by dou v. This is same as alpha into dou by dou x of dou z by dou u plus beta times dou by dou x of dou z by dou v equals to alpha times, here again the same thing. So dou by dou x of dou z by dou u, we can write it as dou by dou u of dou z by dou u into dou u by dou x plus dou by dou v of dou z by dou u into dou v by dou x. Same thing for the next term, beta times dou by dou u of dou z by dou v into dou v by dou x plus dou by dou v of dou z by dou v into dou v by dou x. This you can write it as dou square z by dou u square, dou by dou x is 1 plus this is nothing but dou square z by dou v dou u into 1, this is 1 plus beta times this is dou square z by dou u dou v, this is 1 plus dou square z by dou v square into 1, this is also 1, this is dou square z by dou v square. So this is written as alpha into dou square z by dou u square plus beta into dou square z by dou u dou v, Actually we can combine these two terms because both are same. This is alpha plus b, we can write alpha plus b times this plus beta times dou square z by dou v square. Therefore, the given PDE is nothing but dou square z by dou x square minus 5 into dou square z by dou x dou y plus 6 into dou square z by dou y square. This is a given PDE. We have to transform into this type. We have to transform to this type. That's what we are trying there. So what happens, you make the substitutions. So what is dou square z by dou x square? So we found in the beginning. Yes. Sorry, here. Actually, this can be written in a shorter form notation. The notation we use is z u plus 2 into z uv plus z vv. Z suffix uv means dou square z by dou u square. Z suffix uv means this. So we can use this shorter form. So dou square z by dou x square is nothing but z uu plus 2 times z uv plus z So now we make the substitutions now. Z UU plus 2Z UV plus Z VV minus 5 times, and the remaining things you can check it from 5 into dou square Z by dou X dou Y. This is nothing but this term. Okay, that is alpha times Z UU plus alpha plus beta times Z UV plus beta times Z VV plus 6 times dou square YZ by dou Y square, this term. So here it is 6 times alpha square Z UU plus 2 alpha beta into Z UV plus beta square into Z VV is to 0, which implies after some simplifications we get 1 minus 5 alpha plus 6 alpha square into Z UU plus 2 minus 5 times alpha plus beta plus 12 alpha beta times Z UV plus 1 minus 5 beta 1 minus 5 beta plus 6 beta square into Z UV equals to 0 after all simplification. Here I have to bring it to this format. What is given in the problem, I have to bring it to this format. So only dou square UZ by dou U dou V must be there and other terms must be 0. So when is it possible? So we have to equate this and this is VV. This is UV. So these two things must be equal to 0, which implies ZUV equals to 0 if and only if these two terms, what are they? 1 minus 5 alpha plus 6 alpha square may equal to 0, and 1 minus 5 beta plus 6 beta square must be equals to these two terms, these two equations must be 0. That is, so from the first equation, that is a quadratic in alpha, we get 6 alpha square minus 5 alpha plus 1 equals to 0, implies we get alpha equals to 1 by 2 and 1 by 3. And from the second quadratic equation in beta, we get beta equals to 1 by 2 comma 1 by 3. So now what are the combinations of alpha and beta? For alpha equals to beta equals to 1 by 2, for this combination we get, for this combination so for this combination we get now these two terms, 1 minus 5 alpha plus 6 alpha square and 1 minus 5 alpha 5 beta plus 6 beta square, both these equations will be 0, but we have to check whether this 2 minus 5 alpha plus beta plus 12 alpha beta also becomes 0. That should not become 0. So what is the combination of alpha and beta, so that this 2 minus 5 alpha plus beta plus 12 alpha beta should not be 0? What is the combination? We have to check. So for alpha equals to beta equals to 1 by 2, suppose we take this combination for alpha and beta, then you see we get 2 minus 5 times alpha plus beta plus 12 alpha beta. What we get, we can check. So we get 2 minus 5 times alpha plus beta is 1 plus 12 into 1 by 4 we get. So what is the answer? 2 minus 5 plus 3 equals to 0. So this combination should not be taken because this term should not be 0. So this alpha beta we are neglecting. Then again we take this combination for alpha equals to beta equals to 1 by 3, 1 by 1 by 3, we get the same thing. We get 5 into, we get 2 by 3 plus 12 into 1 by 9. Again this becomes 2 minus 10 by 3 plus 4 by 3 equals to 10 by 3 6 plus 4, 10 by 3 minus 10 by 3 equals to 6. Again for this combination alpha and beta equals 1 by 3 order, this term becomes 0. So the only thing we are going to choose is, let us choose alpha equals to 1 by 2 and beta equals to 1 by 3. For this combination it is non-zero. Therefore we get dou square reset by dou u dou v equals to 0. So this is a combination for which we get this canonical form. Now we are going to find the solution of this canonical form. Now integrating with respect to u, we get partially with respect to u, we get dou z by dou v equals to a function of v, because we are differentiating partially with respect to u. And now again integrating with respect to v partially, we get z equals to integrating partially with respect to v, we get some other function of u as a constant, integrating constant of integration, that is z equals to, I name this function as capital F of v and g of v. So that is z equals to capital F of, what is u given in the problem? You can check. U is nothing but, in the beginning of the problem it is given, the transformation. U equals to x plus alpha y. What is the choice of alpha we have chosen? X plus alpha equals to 1 by 2. X plus alpha y, x plus alpha y, and g of u